we are moving on with section 11-3. We had introduced the first couple of volume equations on Friday. Again, if you had missed Friday's lesson, that is posted to YouTube. As for tomorrow, there are 2 assignments that are due tomorrow. Again, there's the assignment that I gave out with Friday's lesson, and there's the assignment that I'll give out with today's lesson. Again, if you look at the calendar, again, everything has been posted on the calendar. So if you haven't already taken a look at the calendar, again, here it is again. Just to refresh your memories, again, these are the things that you will see on the next test. Those last 2 topics you won't see on the next test. Again, that next test is on May 15th. Now, last week we focused on those top equations for volume. Again, we were only focusing on volume. We did a prism and a cylinder last week. Today, we're going to be doing the pyramid and the cone. So again, we're just looking at volume for today. Later in the week and next week, we'll be taking a look at some of those other formulas for lateral area and surface area. But again, when you're doing volume, you have to know how to find the area of a base. So you got to refer back to all the area formulas from that earlier chapter. Because again, anytime you have a big B in that equation, big B represents the base area. So you have to find the area of the base in order to plug it into that volume formula. Now, same as the last section, height. Again, we're talking about height of the solid. Normally, you use a capital H. Again, this textbook, for some reason, keeps insisting on using a lowercase h. So every time we look at an equation from this book, I'll change it to an uppercase h. Now, this actual section, again, is talking about the volume of pyramids and cones. But we did talk about an idea in the last section called Cavalier's principle. Now, Cavalier's principle said that if you have the same area at every single height, then the solids must have the same volume. Well, just like it was true in any of our prisms or cylinders from last week, you can also do it with cones and pyramids. So with cones and pyramids, if you have the same volume at every single height, then, same area at every single height, then the volume must be the same. So there's 2 examples here on this page that show you this. You have the 2 cones that are stacked, one as a right cone, one as an oblique cone. So again, this one is our right cone. This one's the oblique cone. And again, since we have the same area at every single height, the same circles making it up, the volume of both those figures are the same. So essentially, if you have the same height and if the base is the same on the cone, then you can use Cavalier's principle to say that the volume of those 2 must be the same. They also are showing an example where at each of the heights in a cone in a pyramid, you have the same area at every single height. Therefore, these 2 could also have the same volume. Again, as long as you have the same area at every single height. So with a cone and a pyramid, if you look at the base area and the base area of both of them are the same, then the volume will be the same as long as it has the same height as well. All right. Now, these are the main equations. Again, what I was saying about our book, it's a little bit different than the equation I posted. They had used this little h. Again, they're talking about height of the solid, so we really should be using a capital H when talking about height of the solid. So I'm going to change these 2 to capital H's. Same thing over here. I would change these to capital H's. Now, you notice these 2 equations are very similar to the equations that we already did. The only difference between these equations and the equations that we had on Friday is the 1/3 that's out in front. If we had a pyramid that had the same base area as a prism and the same height as a prism, then the volume of that pyramid would be 1/3 of the prism. So same thing with a cone. With a cone and a cylinder, if you had a cone that had the same base area as a cylinder and the same height as a cylinder, then the volume of that cone would be 1/3 the volume of that cylinder. So these equations are closely related. Again, both of these actually share the same equation to start off. The only reason why there's a second equation for a cone is because instead of just doing big B for base area, a cone will always have a circle for the base. So we're able to plug in the formula for area of a circle in for big B. For the other one, the pyramid, well, this pyramid they're showing is a triangular pyramid, but not all pyramids are triangular pyramids. So again, it depends on whatever the base is. So the big B in this case can be replaced by a number of different equations. It could be replaced by the formula for a triangle, a formula for a square, rectangle, kite, basically any one of those shapes that we had back when we talked about two-dimensional figures, even regular polygons. So again, those are important equations. If you didn't already get that equation sheet printed out from last week, again, this one, I make sure that this one stays somewhere throughout this entire chapter so you can refer back to it. If you can't print it off, then I'd recommend copying them down so that you know which things are using which formulas. So let's take a look at a few examples. Today's lesson is mostly examples because, again, it's just two new equations. So now, the example here, this is talking about pyramids and cones. So the top one, it says that we have a pile of corn, and it says that the pile of corn is shaped like a cone. So it's kind of hard to tell that from the diagram, but there was a note in our book that says that it is shaped like a cone. So this would be using the formula for volume of a cone. Now, it's not only asking us to find the volume though. So again, you gotta make sure you read these questions because this one says, Kyle's truck can haul 1.5 tons of corn per load. 1 cubic meter of corn weighs 0.8 tons. How many loads will Kyle haul to move this pile of corn? Well, before we can do anything, we have to find our volume of this cone. So again, the corn is in the shape of a cone. So we're using that equation for volume of a cone, which you can either do volume equals base area times height, or you can replace the big B with the formula for area of a circle, pi r squared times height. Now again, since this is a cone, we need to add in that 1/3 to both those equations. Because again, when we compare the cone to a cylinder, a cone is 1/3 the volume of what a cylinder would be. So again, if it's coming to a point, a vertex at the top, it's going to be the 1/3 out there in front. Now, we have some dimensions. Well, those dimensions don't tell us everything we need because in the form that calls for height, which yes, they give us the height. This would be our height. But then the 4, that's our diameter. We need the radius. So we got to take that diameter and cut it in half. So instead of 4 meters, the radius is only 2 meters. So now we can plug these into our equation. So we have volume equals pi, 1/3 pi r, which was 2 squared, times the height, which was 1.5. So we can simplify this. We have 1/3 pi, 2 squared is 4, and then 4 times 1.5 is going to be 6. 6 times 1/3, well, that's the same thing as saying 6 divided by 3, so that's 2. So we now have 2 pi. We're going to actually multiply this out because we need to know how much it actually is in volume in order to compare it to what they're having us do in the problem. So 2 times 3.14 gives us 6.28. Now, this is our volume. This is in meters cubed. We need to figure out how much it weighs in order to answer this question because it doesn't say how much volume his truck can carry. It's how many tons his truck can carry. So if we know that each cubic meter weighs 0.8 tons, we need to multiply that 6.28 by the 0.8. So 6.28 times 0.8 gives us 5.024. So that's how much the corn weighs in tons, divided by, well, it was 1.75 that the truck can carry, divided by 1.75, gives us a total of 2.87. Now, how many loads does he need to take? Well, he can't take a partial load. It's either you're running a round trip with that truck or not. So it's going to take him a total of 3 loads. So again, correct answer there was 3. Now, on the next one down, we're looking at a pyramid. And again, it's also, this one is a triangular pyramid, kind of like that first diagram was, but it's upside down. It doesn't matter that it's upside down. It is a pyramid anytime you have one base, and then on the opposite side of the base, there's a vertex, and all the sides that would be the lateral faces are going to be triangles. Again, that's all it takes to be a pyramid. One base, all the lateral faces are triangles, and they all meet at one point called the vertex. So on here, it's upside down, but it's still a pyramid. It says Jason is using the mold to make 12 candles. How many cubic inches of wax does he need? So on this one, again, same general equation. Volume equals 1/3 base area times height. Now, base area in this case is going to be our base, which is a triangle. So for base on this problem, the base area will be found by using the triangle formula, 1/2 base times height. So we're going to replace those pieces with the 3 and the 4 that's here. So this could be our base. This could be our height of the triangle. The 6 over here is the height of the solid. So we have 1/2 base, which was 4, times height, which was 3. 1/2 of 4 is 2. 2 times 3 is 6. So the area, again, this is the area in inches squared. We can now take that and plug it into our original equation for volume. So again, we got to take this and plug it in over here now. So we have 1/3 still. We have the base area, which we just found was 6. We have the height is also 6. Again, you can multiply this in any order you want to. I'd actually multiply the fraction first because 1/3 of 6 is 2. 2 times 6 is 12. So 12, oops, a little lag there. 12 inches cubed. They had a different answer. Did I make a mistake somewhere? 12. Let's look back. Oh, no, I did not make a mistake. This is for one candle. Look back at the question. He wants to make a total of 12 candles. So we have to multiply this by 12 candles. So there's a total of 144 cubic inches. I don't know why this is lagging so much today, of wax. All right. Any questions there? All right, let's take a look at a couple more then. So some of these are a little more basic. Again, this one's just asking us for the volume. So they're giving us the dimensions. That's all we really need. Again, our volume formula for a cone is always the same. It's the 1/3. Again, you can do base area times height, or you can replace the base area with the equation of a circle area, which is pi r squared. So 1/3 pi r squared times height. So they gave us the height. So this is our height. This 14, well, that doesn't help us because that's diameter. But if we take half of that, we'd have our radius. So 7 will be our radius. And those are the only 2 things we have to plug in. So 1/3 pi, the radius is 7 squared, times height is 16. Just multiply this out. Now it doesn't say what to leave it in. You could leave it in terms of pi if you want to, or you could round it. So for this one, again, it's not like the other questions where we had to know the volume in order to do something else with it. So again, it's fine to leave this in terms of pi. If we just multiply this out, 7 times 7 is 49. 49 times 16 is 784. Let me write that down so that the steps are all shown. So I got 1/3 times 9 times 16, which then I said was 784. Oops. 1/3 of that. So divide by 3. You get 261.3 continuous times pi. Now that's not really an exact value because we're kind of rounding that. If you wanted to leave it as a decimal, multiply out the 3.14. And again, depending on what you use for pi, you might get different answers because this is a much larger number. So again, it's important that you try to stick to something. I would say use 3.14 because that's what I'll always ask you to use on the test. I will never say use the pi button on the calculator. I will always say use 3.14. All right, for B, what is the volume of a pyramid with base area of 10 and a height of 7? So again, we just have to know our formula. Volume equals base area times height. In this case, well, they actually told us the base area, so we don't have to do a separate formula for base area. We can just go ahead and plug this straight in. Base area is 10, height is 7, volume is 70. Any questions? All right, let's keep going. All right, here's another one where we're applying volume of a pyramid. So it says that we have a tent on this. It tells us how big the tent is. It tells us that it's 3.4 cubic meters, a square floor with 8.4 meter perimeter, and the height is covered by the sales price there, the clearance price. So it wants to know, could Diane stand in this tent? So it tells us how tall she is, which is 1.8. So we first have to figure out how tall is the tent. So what is the height of the tent? So first thing that we're going to do, I'm going to write my formula. Volume equals base area times height. Now, we know the volume, but we don't know the base area, and we don't know the height. The height is what we're looking for. So we need to figure out what the base area is. Well, in order to do that, they told us that we have a square floor, and they told us the perimeter of the base. So if we know what a square looks like, we know that all the sides have the same length. So if I take the perimeter, which was 8.4, and divide it evenly by 4, that's going to give us 2.1 for each side. So that's, again, for one side. So S is 2.1. So now we know that the volume is, as it stated on the package, 3.4 cubic meters. We know that the base area is 2.1. We do not know the height. Only thing we got to do is divide off the 2.1. And now it tells us that the height, let's see, 3.4 divided by 2.1 is 1.619. 1.619. She is 0.8. I don't think she can stand in this, but for some reason I thought that it said she could. Hold on, let's see what they, oh, sorry, there's my image. I forgot I had drawn that in there. Says she could stand. Let's go back and check the work real fast. Does anybody see a mistake that I am missing? Two 2.1. Oh, I know what it is. 2.1, sorry. On this one, I forgot to square this. This is the length of one side. I needed to square it. That's why it came out a little short. Because again, that's the length of the base and the height of the base. So it's a square. So it's this times itself. So 2.1 squared. So let's make a quick adjustment there. So if I just divide this by 2.1 again, I should have the actual correct answer. But let's go ahead and do the math real fast. 2.1 squared. Yeah, let's erase this stuff for a second. I want it to look nice. And I did spot another mistake. Anybody spot another mistake there? Because I just found something else. Look at my formula. What formula am I using? What's missing? Anybody? Come on, there's about 20 of you guys in here. Somebody has to spot the mistake. What's wrong with my formula? There it is. I got 2 people. All right, thank you. I'm not sure if the rest of you guys are paying attention. Anybody else notice the mistake before I say what it is? So, all right. I am missing, there it is. I got a few other people responding now. I'm missing the 1/3. So 1/3, 2.1 squared times height. That 1/3 is important. I found instead of the volume of a pyramid, I did the volume of a prism. So again, 1/3, that's the big piece that I was making. So missing. So if we take that and multiply this out again, let's try it one more time. And it should give us quite different of an answer. 1/3, 2.1 squared. That's 1.47. Try it again, divide it off. And it gives us a much bigger number. 2.3. Let's just round it there. There's a lot of decimals. 2.3 is our height, which then she can stand. So, yeah, I saw that pyramid there. Oh well. But 2.3, she should be able to stand because she's smaller than the height of the tent in the center. All right, a lot more try it. How much time do we have? That's 30 minutes. I'll come back and I'll do a few more examples if you want to stay on. So again, I'll do these try-its and I'll do this example. If you want more examples, if you don't want more examples, you don't have to stick around. Let me show you the final thing. Again, on this slide, just remember those formulas. That should really be a capital H because that's the height of the solid. Height of the solid. Oops. Height of the solid. Height of the solid. So again, I'd always make that a capital H when we're talking about the height of the solid. This is the work that you need to complete for this lesson. So again, it's out of your textbook. It's those problems, numbers 5 through 13, and then 18 through 24. So again, if you haven't already started on Fridays, you might want to get started on this as soon as possible because again, Fridays and this one are going to be in the gradebook for tomorrow. So I'll post the 2 assignments tomorrow, but again, they're already on the calendar and I've already assigned them on here. So let me go back and do the other couple problems real fast. Again, if you want to stay on, you can. I'm going to do these other examples, but if you don't, again, you can sign off if you want to. I'll post the rest of this to Edsby if you're having trouble. So here we go. On the next chart, it said a rectangular pyramid has a base that has 3 times as long as it is wide. The volume of the pyramid is 75 feet and the height is 3 feet. What is the perimeter of the base? So first we got to start off with our volume formula. Volume equals 1/3 base area times height. A rectangular pyramid has a base that is 3 times as long as it is wide. So it doesn't tell us exactly what the dimensions are here, but we do know something about it. We know the base area is found by doing base times height, or length times width. So let's say that we use x for one of the sides. The other side is 3 times x. So that means that the base area could be represented as 4 times that first smaller unknown side. Well, they told us some other information here. The volume of the pyramid is 75 feet cubed, and the height is 3 feet. So we can go ahead and plug into our volume equation here. Volume, which is 75, 1/3 base area. Again, we don't actually know what the base area is, but we're just going to plug in that 4x right now. The height is 3. Well, 1/3 times 3, those actually end up just canceling each other out. So now we have 75 equals 4x. So divide 75 by 4, and you'd have 18.75 for x. And again, this would be the smaller side. It's a rectangle. So that's one of the sides. The other side would then be that times 3. So 18 times 3 is 56. So if I do 3 times x, or 3 times 18.75, I get 56.25. So if you're picturing this rectangle, now I have side lengths of 18.75 and 56.25. Again, they want the perimeter, so we need to add those both twice. So that's a total of 150 for our perimeter. So if you add up all the sides, the perimeter is 150, and this is in feet. Number 4, a cone has a volume of 144 pi and a height of 12. What is the radius of the base? So again, they gave us some values here. We have to know our equation. 1/3 pi r squared times height. We know the volume, 144 pi. We know the height. Now, first thing we can do, we can go ahead and divide off the 12 and the pi. So I'm going to get rid of the 12. I'm going to get rid of the pi. We're doing the same thing over here. Get rid of the 12, get rid of the pi. So that's going to change this to 12 equals 1/3 r squared. Get rid of the 1/3 by multiplying by its reciprocal, which is 3. So times 3. Whoops, didn't mean to cross that one out. It was the other one I wanted to cross out. So let's cancel out. This is going to give us 36 equals r squared. Square root to get r by itself. So the radius is 6. On part B, if the radius of the cone is tripled, what is the new volume? What is the relationship between the volumes of the two cones? So It doesn't say that the height has changed. It only says that the radius has changed. This goes back to one of the problems that we had done in the last section. You have to remember that when we're talking about the radius, anytime you are dealing with a circle, that radius is like both dimensions. So it's changing kind of, if you think about it in terms of almost like a square, it's changing the base and the height because the radius is the same in every direction. So it's changing two different measurements. So on here, you're actually going to get that radius value squared is going to be the difference for this problem. So on here, if it is, let's see, it says the radius is tripled. So if the radius is tripled, then it's going to be 3 times 3, which is 9. So the volume will be times 9. And again, we can take a look at it as to how it changed it, but I'm saying it right now, it'll be 9 times as much. All right. So let's take a quick look at if we had tripled the radius, because we already know what the volume was of the initial cone. So let's just do an equation and see what it looks like. So we had volume equals base area times height. So pi r, which in the last one was 6. So if we triple 6, that's 18. We're going to go 18 squared times the height, which the height is staying the same. It's still 12. If we multiply that out, 18 squared times 12, that's going to be 3,888 pi. So take the 144, divide by that 144. You got 27. 18 squared. Did I multiply that right? I tripled it. Oh, yeah, here. I didn't go far enough. Let me show you this real fast since we're here. This is something that I'm going to show you in the next section. And actually, this type of problem you will not see on the test because it's going into something else. We talked about scale factor early in the year, which was single dimensional measurements. There's a relationship between scale factor, area, and volumes of similar figures. If we had a scale factor, which we use K for scale factor early in the year, the area would be that squared, the volume would be that cubed. So on this problem, when I came up with the 9, I was a little wrong because I only went to area. I didn't go to volume. I said cubed and wrote squared. There we go. So I only went to area. I didn't go to volume. So we said that the scale factor is a third. Sorry, 1 to 3 or 3 to 1, how you want to look at it. Let's go 3 to 1. So if I took that and squared it, then it'd be the 9 over 1. If I cubed it, that's what we'd have to do here. We'd have 27 to 1. So it's 27 times as much, not 9 times. That'd be the area. All right, that's it for that one. Composite figures. Composite figures, this is anytime we have more than one figure attached. So again, we saw this with our area as well. This time we have 3 different shapes. We have the cone, we have the prism, and we have prisms for the legs as well. Or no, those looks like cylinders. Yeah, they're curved. So cylinders for the legs. So we'd have to do a couple different things. We'd have 3 different formulas that we'd have to make. The first one is the head, which is a pyramid. So for the head, the volume would be equal to 1/3 base area times height, which it looks like a square pyramid since those are both the same length. So 1/3 16 times 16, or 16 squared, times a height of 20. That's going to be for our head. Have a good one. All right, so this is for our head. Then if we do the body, volume of the body, again, that's a rectangular prism, so we can do base area times height. So base area on this one, well, it's saying this is 22, this is 18. So again, those are going to be my 2 dimensions for my base. The height of it's 15, so that's for the body. And then the legs, which we're going to have to do times 4. There's 4 legs, so 4 times the volume of a leg. So 4 times, to find a cylinder, again, we're doing base area times height. So we're going to have 4 times, the base area is the area of a circle formula, pi r squared times height. So plugging in the radius and the height, the radius is 2, because that 4 is the diameter. The height is 16, because again, it's the perpendicular distance between the bases. So now we have our equation set up. All we gotta do is multiply them out. So 16, oops, I didn't substitute height on this one. 20 was our height on this one. So let's add that in there. So on this one times 20, okay. Multiply it all out. 16 squared times 20 divided by 3. Got 1706. Now, that's going to be, that's rounded though. And we should actually round up because the next value is A6. So 1707. Let's just round it off there for now. Then the body, 22 times 18 times 15. That's going to be 5,940. For the leg, we have 4 times 16 times pi, 3.14. That's 201, pretty much, if we round it off. So we still have the 4 times 201. So got to multiply that by 4 since there's 4 legs, times 4. That's 804. So now add those numbers up. 5940, 1707, 804 plus, and that gives us a total of 8450. Oh, I still have that one as a decimal in my calculator, so let's change that to a 1. All right, so now that's not the final answer. It wants to know how many bags of concrete does she need. So the concrete makes that many cubic feet, so 0.6 cubic feet. So it's going to be a lot of concrete. So divide this by that 0.6. So 8451 divided by 0.6. That's a lot of concrete. Let's see if I got the same answer here. Yeah. So on here, they say that there's 9 bags of concrete. So one thing that you do have to do in the end is change the inches to feet. So everything that we found so far was in inches. So we do have to take this number down here and change this into cubic inches, or we could change it into cubic feet. If we want to change this into cubic inches, we'd have to multiply this by 12, to the 3rd power. So let's just see if this works out, because everything else looks like it's correct so far. 0.6 times 12 times 12 times 12. That's 1,036.8. And if you divide 8,451 divided by 1,036, you get just over 8 bags. It's 8.15, which is 9 bags if you round it up, because you can't go be short. So that'd be it. That was a long problem. All right, we'll stop there. There was one other example, but again, it's kind of the same thing. It's just instead of adding, it'd be subtracting. So you have two shapes on that one. You have the triangular prism and a cone. You just subtract the volume of the cone from the triangular prism. All right, I need to go off to my next class. So I hope everybody got a little bit out of this. I will post this on Edsby with a link to YouTube. I'll also post the filled in notes. Any questions before I go? And again, tomorrow I'll be on for office hours at the same time as usual, 12:45 to 2:15. If you have questions, you can come by and ask me then as well. All right, I don't see anything, so I'm going to go ahead and end this. Have a good day.